In this section, we're going to be talking about the surface area and volume of composite objects. Now, the entire idea behind composite objects, which we had discussed in grade 9, is the idea of you just have more than one object kind of put together. For example, we have a hemisphere and a cylinder. So because we have those two things together, well, we're going to have to find out, we're going to do the surface area and volume. So if we want to find out the surface area, we'd have to take the hemisphere and add the cylinder. So we have two parts that we really have to do. The hemisphere, well, our formula is 4 pi r squared, but because it's only half of it, we'd have to divide it by 2. For the cylinder part, to find our surface area, the entire formula is 2 pi r squared plus 2 pi RH. But the only issue with this formula is this 2 is indicating that there's 2 circles of surface. Because this hemisphere is completely over top of the cylinder, we would not have 2 circles, we would just have the 1, which means we can then plug our things in. Of course, I certainly encourage us to use reduction. So we'd have the 2 pi, our radius is 18. Plug that in for all of those r's. Oh, sorry. And our height of the cylinder is the 32. So if we have all of those individual parts, 2 pi multiplied by 18 squared. Before we get to final answers, I certainly encourage using 4 decimal places. So 2035.7520. There we go. Pi times 18 squared would be 1017.8760. And 2 pi multiplied by 18 multiplied by 32 will be 3,619.1147. We add all that together. Should come out as, and we'll go 2 decimal places. 6,672.74. Now I've done a little bit more. It may be, if you type it in your calculator, you might have it slightly different. It might be a 3 or a 5, but I've just included all my calculations. So there's my answer. For the volume, well, we're also going to be doing the volume of a hemisphere and a cylinder. For the hemisphere, it's 4 pi multiplied by the radius cubed divided by 3, but then we would be dividing it by 2. We'd then have to add the volume of the cylinder, which is pi multiplied by the radius squared multiplied by the height. Of course, I'm going to do a quick little bit of manipulation here. For example, dividing by 2 means multiplying by 1/2, which means I can then reduce my 4 and 2 to give me a 2. So when I plug it into my formula, all I'll have to do is use the 2. My radius still is 18 divided by the 3, adding pi multiplied by 18 squared multiplied by our height of 32. So 2 pi multiplied by 18 cubed divide that answer by 3. I get 12,214 0.5122. And the pi multiplied by 18 squared multiplied by the 32 is 32,572.032.6. You add it together. And we get 44,786.54. And our unit would be centimeters cubed. So not too bad, especially when everything is straightforward. If things are not completely straightforward, we'll have to do a little bit of extra work. So if we're finding out the surface area, well, we're going to be finding out the surface area of the pyramid, adding the surface area of the cube, which is just a square-based prism. Now, the biggest thing is on this pyramid, well, the only things that are exposed are these four triangles. We don't have to worry about the bottom. So we have four triangles. 4 multiplied by base times height divided by 2. Adding our cube, well, each of these sides are all the same. So length times width. Some people use side squared, but length times width is perfectly fine. At the same time, the amount of exposed sides are 1, 2, 3, 4, 5. Left and right, front and back, and bottom. So we'd only have to be multiplying it by 5. We can reduce our 4 and 2 to give us a 2. So for the pyramid, which is the triangular bases, our base of each triangle is 5. The height of each triangle is 4. 5 multiplied by our, and each of these sides are 5 by 5. So let's see, we have 10 by 4, which is 40. 5 is 125, which means we get 165 meters squared. To find out our volume, again, we're going to be finding out the volume of the pyramid and the volume of the cube. So the volume of the pyramid of any kind of pyramid is the area of the base multiplied by the height divided by 3. For the cube, well, it's just going to be length times width times height, which is the area of the base times by the height. So the good news is our area of this base is just going to be a 5 times 5. The height of this pyramid is something that we're going to have to calculate, because we don't know what is the actual height of the pyramid. So let's calculate it out. The good news is we have a right triangle. The hypotenuse is 4, and this side will be half of 5, which is 2.5. So by using our Pythagorean theorem, a squared plus b squared equals c squared. Of course, I would not expect that you'd have to write down the formula all the time, but I would expect that you'd be plugging your values in. Let's call this our height. So our height squared, add our 2.5, because that's the leg of the right triangle. The 4 is the hypotenuse. So our height squared, 2.5 squared is 6.25. And 4 squared is 16. So when we subtract off our 6.25, the height squared would be 9.75. Take the square root. (9.75 to the power of 1/2). The height of the pyramid is 3.1225. Now, when I'm plugging this in my calculator, I'm actually going to, no, I'm not going to leave it at 5 here. I'm going to put it as the 4 because I know how to use my calculator. It's 4,98999. So I'm going to leave that in my calculator. But when I plug everything in, I'm going to have exact values. For the cube, the length, width, and height are all 5, 5, and 5. So if I take my 3.1224, which is still in my calculator, I multiply it by the 5 times 5, and I divide it by the 3, I get 26.0208. 5 times 5 times 5 is 125. So our final answer would be 151.02 meters cubed. Now we have our volume. So a lot of the things that we do is we have to be able to use our common sense to identify what we need. To find out the surface area of this one, well, we're going to be finding out the surface area of a triangular prism, as well as adding a rectangular prism. The only issue, though, is in our triangular prism, this one rectangular side is not exposed. At the same time, the rectangular prism, that same side, is not exposed. So we have to use our common sense and identify the things that we can actually do. For example, we have two triangles. So base times height divided by 2, multiplied by 2. Again, I say that you need to be showing this. You need to show that you know how to find out the area of a triangle and you know that you're multiplying it by 2. Now we have two rectangles on this triangular prism. It doesn't specifically say, but because of our height and because this side is the same as this, these two sides would also be the same. Now it's not going to be the exact same as this. So that's something that we're going to have to calculate what that is. Well, we'd still have 2 length times width. For our rectangular prism, so that's the rectangle part. For the rectangular prism, we have a left and a right. So that'll be the left-right calculation. We have a front-back calculation, which will be this one and this one. And then we have a bottom, which is just you'll see that this left-right, there would be 2 of them. Same as the front and back. There would be 2 of them. So we can plug in what we have. For example, the base of this triangle is 4. The height of the triangle is 3. Now we've already been dividing by 2, multiplying by 2. For the rectangles, we'd have 2. We know that the entire length of it is 6, but we don't know what the width is. So we're going to have to calculate it out. We know that that's 3. This would then therefore be 2. So we'll call this, oh, we've labeled it W, so let's call it W. So W squared, oh, sorry, not plus, because that's our hypotenuse, would equal 3 squared plus 2 squared. So 3 squared is 9, 2 squared is 4. That would come out as 13. Take the square root, and the square root of 13 comes out as 3.60. I know that I can leave that all in my calculator, so I'm just going to leave it in my calculator. Alrighty. So for the left and right, it would have dimensions of 6 by 5. For the front and back, it would have a 4 by 5 measurement. And our base length and width would be the 4 by 6. So I can do a few things in my head. I'll leave that one just for a second. Let's see, that one should come out as 60. That one should come out as 40. And that one will come out as 24. So when I plug that one in my calculator, so again, I still have that in my calculator, multiply by the 2 and 6 to give me 43.2666. I add that with my 12, my 60, my 40, and my 24. I get 179.27 unit feet squared. And last but not least, to find out our volume, for any prism, it's always the area of the base multiplied by the height. See, I'm gonna just have a little fun here. So this one we will calculate for the triangle. This one is going to be the rectangular base prism. So the base of this triangular prism, well, would be a base times height divided by 2. And then we're going to have to multiply it by the height of it. This rectangular prism, the area of the base is length times width, multiplied by the height of it, which will be height. So for the triangular base, the base of the triangle is 4, the height of the triangle is 3. Divided by 2. The height of the triangular prism is 6. Length, width, and height of our rectangular base, 4, 6, and 5. Doesn't necessarily matter which order you write these in, because order and multiplication doesn't really matter. So 4 by 3 divided by 2 times 6, 36. 4 by 6 by 5, 120. So we get 156 feet cubed as our volume of this entire composite figure. Now you may be given figures that this is actually inverted. So you're actually going to be you're going to be still finding out different things. You may be subtracting different things. For example, this looks like a house. There may be situations where you have a door. Well, you're going to have to subtract off the area of a door. But that wouldn't affect your volume. So now that we've done our composite objects, Again, the surface area being the review of grade 9. Volume is something slightly different for grade 10, but it's not a huge stretch, and that allows you to go have some fun. Now you will see on your assignment though, for practice, I would like you to calculate the volume for number 3, and I should have these calculated correctly. Let me know if they're not. Alrighty, go have some fun.